So dear students, welcome to our class on Micrometeorology of Crops, Temperature 3. As I said, temperature measures the average energy of the individual molecules, whereas it is energy. Heat measures the total molecular energy. So from there we started our Micrometeorology of Crops, Temperature 1. And in the 2, we have discussed something about first law of thermodynamics, second law of thermodynamics, and the third law of thermodynamics. The first law of thermodynamics, its application also we tried. The energy entering into a system is equal to energy stored in the system plus energy going out of the system. In other words, energy can neither be created or destroyed. It cannot be destroyed. So second law of thermodynamics, entropy, enthalpy. Third law of thermodynamics, when absolute zero temperature approaches, no atoms move. That means no physiological activities. From there, we start our journey. In today's class, we try to understand some applications with the basics we have learned of the micrometeorology of crops temperature. The first one is the earth and atmospheric temperature. This is very interesting. We call it as the EAS. In any book, particularly Western books, if you find EAS, Earth Atmospheric System. Here, slightly different word I used. What is it? Earth and atmospheric temperature. Nothing more than that. Now, see, because temperature determines the distribution of the crops. Temperature also determines the exchange of gases between the crop and the environment. It also determines the translocation of enzymes. Stability of enzymatic reactions is a function of the temperature of the air and soil. So that's such an important temperature. We should know what exactly is the temperature of atmosphere and temperature of the earth. There is a difference between these two. So if you take earth as a spherical body, and of course sun is stationary, because earth is a spherical body, the elevation of the sun, the atmospheric conditions and time of the year determine the temperature of the not only atmosphere but also earth. Okay, here the atmosphere without without the presence of atmosphere, the earth temperature is how much? With the presence of the atmosphere, how much is the temperature? Please write down two small lines, very, very small lines of 4 or 5 words. Please write the effective average temperature of the Earth atmosphere system. Please write the effective average temperature. Effective. Please write that important. The effective average temperature of the Earth atmospheric system, EAS, that's what I told 1 minute back. Without the atmosphere, okay, is 253 kelvins, 253 kelvins. Now, please write another small word. I will explain to you later. Nothing to write after this. The area averaged temperature of the Earth is the area, lithosphere, hydrosphere area, because it is spherical in shape. Of course, radius, that fundamental courses I have defined already. The area average temperature of the Earth is 283 kelvins. 283 kelvins. Now, here important point is nothing to write. The greenhouse effect due to the presence of the atmosphere keeps the Earth's surface temperature about 30 kelvins. 30 kelvins above what would be without the atmosphere. Here is the important point. If atmosphere is not there, what would have been the temperature of the Earth? It is 253. If atmosphere is there, it is 30 kelvins more. That is 283 kelvins. Why? Because sun's energy is coming, whether it is coming in the form of waves or photons of different theories or ray theories or a combination of it, energy is coming from the sun. There are two things are there. Number one, short wave radiations. Again, long wave radiations also come from the sun. Now, Earth is receiving it For the short wave radiations up to 3 microns, so highly transparent. Atmosphere is highly transparent. However, for the long wave radiations, it is slightly opaque. So, CO2, O2, H2O, water vapor, carbon, see all these things, they absorb, they increase the heat. Now, next thing what happens here is, once the short wave radiations are falling on the earthly bodies, the earthly bodies absorb it, they emit it. So, what is happening? Earthly bodies gives, that is the terrestrial bodies gives thermal radiation, that's what we call it. Please note, thermal radiation is equal to terrestrial radiation, that's it. Once again I repeat it, thermal radiation, please write, thermal radiation is equal to terrestrial radiation. So that means this is a major component. Here why I am telling you, as far as micrometeorology is concerned, we are concerned with this particular. So there are innumerable difficulties. What exactly is the incoming long wave radiation? What exactly is the outgoing long wave radiation? However, the difference between the outgoing long wave radiation or thermal radiation minus the incoming long wave radiation is equal to effective long wave radiation. Once again I repeat it. This is the crop. Presume that this is the crop of 1 acre. Now, the difference between the long wave radiation or thermal radiation or terrestrial radiation, the difference between the terrestrial radiation or thermal radiation and the incoming long wave radiation from the sun is known as the effective long wave radiation. This is what is very, very interesting. Crop response to this. Why? Very important. Next things based on this only, that's why I am telling. Here, even in the absence of the sun also, the terrestrial bodies release thermal radiations or terrestrial radiation, which is converted into temperature, or you can say heat. Now, that particular night temperature, it is because of the greenhouse effect, which we discussed very elaborately in climate change. Now, second thing in today's class is cardinal temperatures. So, way back in I can say 1946. Parker, 1946. Parker had defined for cool season crop, for hot season crop, some cardinal temperatures he defined: minimum, optimum, maximum. For cool season crops, the minimum cardinal temperatures are 0 to 5, optimum 25 to 31, maximum 31 to 37. I repeat for your academic interest, say just like oats, wheat, barley, for these crops, minimum 0 to 5, optimum 25 to 31, maximum 31 to 37. Now, coming to the hot season crop like sorghum. Now, maybe in vegetable crops you can say some melons, all these things. Minimum 15 to 18, optimum 31 to 37, maximum 44 to 50. I repeat for your academic interest, 15 to 18 minimum, 31 to 37 optimum, 44 to 50. These are all in degrees centigrade, not degrees Fahrenheit. Now, here, these are the cardinal temperatures. Optimum cardinal temperatures only the growth develops. Now, when we just look at the Hoff's law, Q10 law, that's also we call it. This applies basically as far as our agricultural crops are concerned, from vegetative to reproductive phase only. In my experience, Hoff's law, we applied up to these stages only. Here, for every 10 degrees centigrade, there is a double increase in the dry matter production. That is the Hoff's law. Why we have gone for Hoff's law here? Because in the cardinal temperatures, before that earth atmospheric system, before that the long wave radiation. So temperature, the importance of temperature at the micro level, for every 10 degrees centigrade the dry matter production doubles. Now, another important thing is growing degree days. In this class, that's what we are going to discuss. Growing degree days. The concept is very, very interesting. G.D.D is equal to T max, maximum temperature of the day, T minimum by 2. That means average minus TB. This is the base temperature. Base temperature. Now, so what is the base temperature? If you go to third law of thermodynamics, below which no physiological activity takes place. What is below which? Absolute temperature. However, here base temperatures are not zero. That's what you should remember. Base temperatures as far as my works are concerned, my experience in certain international organizations and national organizations, as far as Asia is concerned, for Kharif crops 10 degrees centigrade, for Rabi crop it is 5 degrees centigrade. We have worked out depending upon the developmental stage of the crop. You youngsters in agricultural meteorology may develop for individual crop, whether it is oilseeds, pulses, cereals, whatever, even for plantation crop. At least for the flowering period you can do it. That's what is my request to you. Now here, G.D.D concept. Why G.D.D concept? Here we come. When Hoff's Law says that for every 10 degrees centigrade there is a double in the dry matter production. Vegetative phase, reproductive phase, maturity phase of the crop is there. Vegetative, reproductive, maturity. Usually the physical dry matter you can see physically up to these two phases. Here it applies. Now, growing degree day concept is excellent with reference to how much duration a crop takes. How many growing degree days, if it is accumulating in the vegetative phase, the reproductive phase would be very optimum. Based on vegetative and reproductive, how much is going to be the maturity stage dry matter produced. Here, please note that another thing, here, application of tea resins. Here I would like to share with you two examples of one is strawberry, second is rice. Here I discuss after telling these two, after informing you these two examples. Strawberries require low morning temperatures of 50 degrees Fahrenheit. Low morning temperature, particularly at the ripening stage. Okay. Now, if it is more than that, if it is less than that, there is no sweetness, there is a formation of acid, there is no aroma of strawberries. If the temperature is morning temperature, particularly during the harvesting, particularly during the maturity, it is there. In higher latitude areas like Sweden, say for example Alaska, always the morning temperatures are 50 degrees Fahrenheit morning. So, strawberries from Sweden and northern parts, okay, or Alaska are always very good aroma of strawberries as compared to strawberries grown in relatively lower, not exactly lower, exactly near the equator, it won't grow. So, in between the temperate regions. Why? Because low temperatures of 50 degrees Fahrenheit is essential for aroma of strawberries. Another classical example is if you take the paddy crop, this bit will come, you may be asked in the question. In China, the paddy yields are, say, 1 unit. In India, the paddy yields are 1 minus 20%. Okay, why it is so? Yes, I am giving you the answer. First, in India, certainly it comes under the, of course, okay, tropical region, okay, tropical humid region where the temperature range is less. All these things are there. Most important thing is in China, in temperate regions, what happens is the photosynthetes, or in other words, let us see, chemical compounds, the carbohydrates move slowly into the grains, number one, move slowly, but it takes a longer period in the grain. Next thing is not only moving of the carbohydrates into the growing period, into the growing grains, but the ripening period is more there. That means more of the carbohydrates are stored in the grains of the paddy. One of the reasons I am telling from micrometeorology of the crop. Okay, so you please write these technical words for your academic interest. Please write. I would be very happy because questions are there in SRF, not in GRF. Now, please write with low temperature. Please write with low temperature. The transportation of why in China rice yields are more as compared to India. With low temperature, that is China areas in temperate areas, China temperate areas. With low temperature, the transportation of carbohydrates, to the grain is slow. But lasts for a longer period. Please write. The transportation of carbohydrates is slow, but for longer period. Number one. Number two, please write. This results in higher grain weight. This results in higher grain weight under low temperature conditions, number 1. 2, please write another important point. Senescence of leaves occurs. Senescence, that means falling of the leaves after the maturity stage, after the maturity phase. Okay, senescence of leaves occurs late, and ripening period of grain is prolonged. Senescence of the leaves occurs. Please write, senescence of the leaves occurs late as compared to India. Senescence, leaves falling, and ripening period of grain is prolonged. Therefore, higher grain weight will come. Higher the grain weight, more the yields. So, this is what I would like to discuss in this class. Thank you for your patient hearing.